Okay, so continuing with our double distribution extension here, we're going to take a look at example number 2. This one gets a little bit more complicated because, as you can see, we don't have just pieces with exponents of 1. We've got pieces with exponents of 2 and 3 and all sorts of crazy things going on. So again, we're just going to take it one piece at a time. The first piece that's jumping out at me that needs to be distributed to that second set of parentheses only is that 7y. So the first thing that needs to get multiplied by, again, skipping the negative y squared because that's in the same parenthesis. I don't want to do that. I want to give it to the other set of parentheses. So 7y to the first, because remember that little 1, 7y to the first times y cubed is going to turn into 7y to the fourth. And 7y to the first times negative 5y squared. Negative 5 times 7 is negative 35. And y to the first times y squared is y to the third. Okay, next piece. That negative, not forgetting that sign, that negative y squared, or negative 1y squared. That's going to give me a negative y squared times y cubed. That would be y to the fifth. Because again, if I expand that, y times y times y times y times y would be y to the fifth when I expand that or condense that. Negative 1 times negative 5 turns into a positive 5, and y squared times y squared turns into y to the fourth. I do have a little set of like terms here, the y to the fourth and the y to the fourth. Again, I'm just going to reorder things. That highest exponent is going to come first, so I'm going to rewrite that negative y to the fifth first. 7y to the fourth plus 5y to the fourth is going to be a positive 12y to the fourth. Apples plus apples stay apples. They don't turn into y to the eighths. And then just carrying down that minus 35y cubed, so it's not left by itself. And there we have our final simplified answer with no like terms. Yes. Okay, example number 3 is the last one we'll take a look at here. This one reminding you to follow order of operations, inside those parentheses. Actually, no, this one you could actually do whatever you wanted first. You could double distribute between these two parentheses, then deal with that piece on the outside, which actually, let's do that. I think that'll be the best thing to do. So as of right now, because again, with multiplication, this really has its own set of parentheses. I can move all these things around and deal with them at a later time. So I'm just going to carry down that negative a squared, and I'm going to deal with that later. So first off, I'm going to start with double distribution, my binomial times my binomial. And I'm going to start with distributing that b first. B times a, 1b times 1a. I'm going to keep my parenthesis here. Is going to turn into BA or AB, doesn't matter. And B times B is going to turn into a positive or plus B squared. Okay, next piece to double distribute is my negative A. Negative A times a positive A is going to be a negative A squared. Negative A times a positive B is a negative, because my signs are different, and A times B is just AB. Cool. We can check to see if there's any like terms to simplify here, which there definitely is going to be. I have, remember, this positive 1AB and a minus AB. So that's actually going to cancel out really nicely for me and leave me with just B squared minus A squared inside my parentheses. Whew, okay, now we have that last set. It is okay if I kept this in parentheses. That shows me multiplication, just like not having the parentheses does. Need those parentheses, though. So now I'm going to take that negative a squared and do my last set of distribution. Negative a squared times b squared, nothing to really simplify there, so that's just going to turn into a negative a squared b squared. And here I do have common bases, so I can do some simplifying. The negative times the negative will be positive, and a squared times a squared is a to the fourth. No more like terms from there, so I'm done. Take your time on those practice problems as they do get a little bit complicated towards the end, but you can do it.